This video is going to be the first in a series about the coronaviruses. I remake these videos every once in a while because the situation with COVID-19 keeps changing, and that's what we would expect. The two of the major coronaviruses we care about the most, which are SARS and MERS, aren't changing much. So I'll talk about those first. So just for your understanding, I'm making this in November of 2022. So at this time, we have been in the era of the Omicron subvariant for about a year, and we see other subvariants coming, but generally there is not a lot of COVID activity. So that's kind of where we're at right now as I'm making this video, and I'll talk about COVID later on. But I want to start with the coronaviruses in general. This is a family of viruses that we've known for many, many years because a lot of them cause the common cold. So the common cold is caused by hundreds of viruses, and the coronaviruses are one of the large groups that contributes to that. So that was known for a long time, and what was surprising was in 2003 when SARS appeared. And then 9 years after that, MERS appeared. And then a few years later, COVID. So we'll start with SARS. It's the severe acute respiratory syndrome. This is caused by SARS-CoV, and I remember this happening. We heard about a mysterious and scary virus in China. I remember hearing about it in Hong Kong, and it was very contagious, very difficult to contain, and deadly. In fact, we have a pretty good estimate of its fatality rate, and even with medical care, it was something like 10%. So that is a very high mortality rate for an easily transmissible virus. Another thing that has made this particularly tragic was that to get SARS, you have to be pretty close to a person who has it. And so a lot of people who got it were nurses and doctors who were treating SARS patients because there was no known way to prevent it or treat it, really. And so there are stories of an entire hospital ward, I think in Hong Kong, where it was like 50% of the nurses were out. A lot of the doctors were out, and a large fraction of them died. So that is horrible, as you can imagine. So some distinct things about SARS, this disease, is that it was almost always a symptomatic infection. That means it always had signs. So a person typically would have pneumonia in the worst case, but they'd always get fever and they'd be sick. So that made it kind of very noticeable, but also it made it possible for a public health response to work. People could do contact tracing. They could figure out who had gotten it from who else and quarantine people. Also, it was most transmissible when a person would be the sickest. And that is not the case for every disease. That's not the case with COVID. That's not the case with most influenza strains. But it was the case with SARS, and it was the case of the 1918 pandemic influenza strain, where when a person is sickest, that's when they're most likely to transmit it. And so that meant that it didn't spread like COVID does. It spread slowly. It spread just among people who were in close contact because it spread by large droplets on surfaces. And there was no vaccine. And really the outbreak of SARS ended fast before a vaccine could ever have been made at that time. Though there's fear all over the world that SARS could come back because no one knows exactly where it came from, probably from a bat, but no one knows where the next one could come from. And so there was a strong push to develop a vaccine for SARS. And that's what gave us the technology to make the messenger RNA vaccines now used against COVID. And that the system they made for developing those quickly for SARS was what let them develop them quickly for COVID. So there is that. Again, it was relatively easy to identify people who had SARS because you could just take their temperature. And a healthy person typically would not have a fever, but someone with SARS would. And so airports put up these thermal cameras. So anyone walking to board a plane, it would take a picture of their forehead and figure out if they had a fever. And so they were able to stop people and catch them at the airport and quarantine them. And because of that, it didn't spread all over the world. It didn't spread to every country or anything like that. It spread to a few countries in East Asia and the US and Canada, and maybe a few others that I've forgotten. But there were like limited cases, and each of them had a big public health response and quarantines and contact tracing. But if they hadn't figured out that they could identify these people through thermal imaging, it would have spread faster. And again, because we could figure out who had SARS, we could quarantine just that person, and we could figure out who they'd been around and quarantine them. So there was no need to shut down a whole city. We could just do contact tracing and limited quarantine, and that worked with SARS because it wasn't super contagious. You'll note I've mentioned MERS, the Middle East Respiratory Syndrome, and that's not one I'm going to cover in much detail. Just know that that is a disease that has sporadically appeared in the Middle East, and it appears to jump from dromedary camels to humans. And that is another serious disease that has an apparent even higher mortality rate than SARS, but it's not as easy to figure out who has it, and so we don't really know how many asymptomatic cases there might be of the Middle Eastern Respiratory Syndrome. And it does not seem to spread from person to person, except in very limited cases with close contact between people. So it hasn't spread out of the Middle East that I know of. So let's leave this one here and move on to COVID.